It would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in all of physics. The announcement of a possible explosion from the Betelgeuse star in the coming weeks has generated an immense wave of excitement and intrigue in both the scientific community and the public at large. Michio Kaku, a renowned theoretical physicist known for his ability to explain complex phenomena in accessible terms, has recently shared predictions that Betelgeuse, one of the brightest and most well-known stars in our night sky, is on the verge of a supernova explosion. This event could have extraordinary consequences, not just for the cosmos but potentially for our solar system and Earth itself. Before we start, hit the like and subscribe buttons for more exclusive news. Betelgeuse, a red supergiant located in the constellation Orion, has long been of particular interest to astronomers. Its size and luminosity make it one of the most easily observed stars, even with the naked eye, and for years it has captured the attention of scientists due to its somewhat volatile behavior. Betelgeuse is nearing the end of its life, and while the timeline for its death has always been uncertain, recent observations have suggested that the star is undergoing dramatic changes. The dimming and brightening cycles it has displayed, especially the unprecedented dimming observed in late 2019 and early 2020, have raised speculations that its time might be much shorter than previously thought. If Betelgeuse were to explode as a supernova in the near future, the event would be one of the most spectacular celestial displays ever witnessed by humanity. Supernovae are among the most energetic explosions in the universe, and the sheer force of such a blast can outshine entire galaxies for brief periods. For those on Earth, the explosion of Betelgeuse could provide a light show unlike anything ever seen before. At its peak, Betelgeuse could shine as brightly as a full moon, visible in daylight for several weeks or even months. While such an event would be awe-inspiring to witness, Michio Kaku's prediction that the explosion could have a direct impact on Earth raises serious questions about the implications for our planet and the broader solar system. Supernovae are not just visually impressive, they also release massive amounts of energy in the form of radiation particles and shock waves. This energy has the potential to disrupt surrounding space environments, and depending on the distance and intensity, it could interact with Earth's atmosphere in potentially dangerous ways. One of the primary concerns in the case of a Betelgeuse supernova would be the emission of gamma rays and cosmic rays. Gamma rays are extremely high-energy electromagnetic waves, and in large enough doses, they could have catastrophic effects on Earth's biosphere. Fortunately, Betelgeuse is located around 640 light-years away, which is far enough that the gamma radiation from its explosion would likely dissipate before reaching Earth with destructive force. However, Kaku has pointed out that even though a direct lethal dose of gamma rays might be unlikely, the radiation could still affect our planet's upper atmosphere, leading to potential disruptions in satellite communications, GPS systems, and electrical grids. Cosmic rays, which are high-energy particles ejected from the supernova, could pose a more significant threat, albeit over a longer period. These rays can penetrate Earth's magnetic field and atmosphere, and while most are deflected or absorbed, an increase in cosmic ray intensity could lead to heightened radiation levels on the planet's surface. This could potentially have consequences for human health, particularly for those in high-altitude regions or frequent flyers. There is also the risk that an increase in cosmic rays could affect electronic devices and technologies, leading to malfunctions or failures. In addition to the immediate concerns of radiation and cosmic rays, there are broader long-term implications of Betelgeuse's explosion. One of the most intriguing possibilities is the effect that such an event could have on our understanding of stellar life cycles and the evolution of galaxies. Supernovae are critical to the process of star formation and the distribution of elements throughout the cosmos. The heavy elements produced in the core of a supernova are what seed future generations of stars and planets, including the very building blocks of life. Witnessing a nearby supernova in real time would give astronomers an unprecedented opportunity to study these processes in action. There is also the question of what impact a supernova could have on other nearby stars. While Betelgeuse is not located in close proximity to any major stellar neighbors, the shock wave from its explosion could still have ripple effects throughout the Orion constellation. This could potentially trigger star formation in nearby gas clouds, accelerating the birth of new stars. On a grander scale, the supernova could also provide insights into the formation of black holes and neutron stars, which are often the end products of such explosions. Despite the potential risks, Kaku and other scientists emphasize that a Betelgeuse supernova is more likely to be a scientific boon than a catastrophe. The wealth of data that could be gathered from observing the explosion and its aftermath would likely answer many lingering questions about supernova mechanics, stellar evolution, and the role of such events in shaping the universe. This would mark a profound leap forward in our understanding of astrophysics, as we have never had the opportunity to study such an event so close to home. The excitement surrounding Betelgeuse's potential explosion is also driven by its significance in human culture. For thousands of years, Betelgeuse has been an important fixture in the night sky, included in the mythology and stories of countless civilizations. Its sudden transformation into a supernova would be a dramatic change in the cosmic landscape, one that could serve as a reminder of the dynamic and ever-changing nature of the universe. For many, the explosion would be a poignant symbol of the cycle of birth, death, and rebirth that governs not only stars but all of existence. The psychological and social impact of such an event could be profound. Humanity has long been fascinated by the cosmos, and witnessing the death of a star up close would likely inspire a renewed interest in space exploration and science. It could foster a sense of cosmic unity as people around the world look to the skies in awe of the same celestial phenomenon. There may also be an increased awareness of our own planet's fragility and place within the broader universe, prompting discussions about our role as stewards of Earth in the context of an ever-evolving cosmos. One of the most intriguing aspects of Kaku's predictions is the timeline, just 2 weeks before the event occurs. While scientists have long speculated that Betelgeuse could go supernova at any time, predicting the exact timing of such an event is notoriously difficult. The fact that Kaku is suggesting such a short timeline indicates that astronomers may have detected significant changes in the star's behavior, perhaps through shifts in its brightness, size, or radiation output. These observations would be critical in refining models of stellar collapse and helping scientists better understand when and how supernovae occur. However, predicting the behavior of a star like Betelgeuse is far from an exact science. While it is clear that Betelgeuse is nearing the end of its life, it is also possible that the star could continue in its current state for decades or even centuries before finally exploding. The timeline for supernovae is notoriously unpredictable, and while the recent changes in Betelgeuse's behavior are certainly noteworthy, they do not necessarily guarantee that an explosion is imminent. Nevertheless, the prospect of witnessing such an event in the near future has captivated both scientists and the public alike. In the days leading up to the expected explosion, astronomers will be closely monitoring Betelgeuse for any signs of increased activity. Telescopes around the world, as well as space-based observatories, will be trained on the star to capture as much data as possible. This will likely be a highly collaborative effort, with scientists from various fields of study working together to analyze the incoming information and refine models of stellar behavior. In addition to optical telescopes, instruments that detect other forms of radiation, such as X-rays and gamma rays, will be essential in understanding the mechanics of the explosion and its aftermath. Public interest in the event will also likely surge as the date of the expected explosion approaches. News outlets, social media platforms, and science communicators will play a crucial role in disseminating information about the event, helping to educate the public on what to expect and what the implications might be. The explosion of Betelgeuse could become a global event, with people gathering to witness the spectacle from different parts of the world. Given the uncertainty surrounding the timing of the explosion, there may be a sense of anticipation and excitement as people wait to see when the star will finally erupt. For many, this event will also serve as a reminder of the unpredictable and often violent nature of the universe. While the stars in our night sky may appear static and unchanging, they are in fact dynamic objects, constantly evolving and undergoing dramatic transformations. Betelgeuse's potential explosion would be a vivid demonstration of this fact, illustrating the power and complexity of the forces that shape our universe. As the anticipation surrounding Betelgeuse's potential explosion mounts, the scientific community and general public are filled with both excitement and apprehension. The possibilities and implications of this event are vast, and while Michio Kaku's prediction has drawn considerable attention, the broader scientific context surrounding such a supernova event extends far beyond the direct consequences for Earth. The potential explosion of Betelgeuse offers a rare opportunity for humanity to witness a cosmic event that typically unfolds over millions of years, condensed into a spectacle that could unfold before our very eyes. When it comes to understanding the full magnitude of a supernova like the one expected from Betelgeuse, it is important to recognize the scale of such explosions. A supernova represents the final death throes of a massive star, a process that can unleash more energy in a few seconds than the sun will produce over its entire lifespan. This energy manifests in a variety of forms, from intense bursts of light to waves of high-energy radiation and streams of particles moving at relativistic speeds. Here's the revised text as requested. These events are fundamental to the universe's chemical evolution as they are responsible for creating and dispersing many of the heavy elements that form planets, life, and even the human body. At the heart of a supernova, nuclear fusion reactions within the star's core cease as the fuel that sustained the star is exhausted. For Betelgeuse, this would mean the end of its ability to fuse heavier elements, which ultimately leads to the collapse of its core under the force of gravity. This core collapse is what initiates the violent explosion known as a Type II supernova, sending shock waves through the outer layers of the star and ejecting matter into space at incredible velocities. The material ejected by the explosion is rich in elements such as carbon, oxygen, and iron, which are essential for forming new stars and planetary systems. The explosion of Betelgeuse, if it happens as Kaku predicts, would allow astronomers to gather invaluable data on the early stages of supernovae, especially in terms of how the shock wave propagates through the star's outer layers. This has profound implications for astrophysics because supernovae are notoriously difficult to study in their early stages. Most supernovae occur in distant galaxies, and by the time their light reaches Earth, much of the explosion's finer details have already faded from view. A nearby supernova like Betelgeuse would be a game-changer, providing an unprecedented window into the explosion's mechanics as well as a detailed look at the composition and structure of the star in its final moments. There is also an opportunity to study Betelgeuse in multiple wavelengths of light, from visible to infrared, ultraviolet, and even radio waves. Each of these wavelengths reveals different aspects of the explosion. For example, infrared observations could show how the dust and gas ejected by the supernova cool and condense over time, while ultraviolet and X-ray observations could help scientists understand the shock wave's interaction with the star's outer layers. Radio telescopes could detect the synchrotron radiation produced by charged particles accelerated by the explosion, giving further insights into the complex dynamics at play. This multi-wavelength approach will provide a more complete understanding of supernovae than ever before, allowing scientists to refine their models and simulations. Currently, much of what we know about supernovae comes from theoretical models that are based on data from more distant events. While these models have proven effective, they are still limited by the data available. Betelgeuse's proximity to Earth means that any explosion would allow for direct observation and real-time adjustments to these models, potentially revolutionizing our understanding of stellar death and the life cycles of massive stars. One of the more speculative but nonetheless fascinating possibilities surrounding the explosion of Betelgeuse is the formation of a black hole or neutron star in its aftermath. When a massive star like Betelgeuse explodes, what remains after the supernova depends on the star's mass. If Betelgeuse is on the lower end of the mass spectrum for supernova candidates, it may leave behind a neutron star, a dense, rapidly spinning remnant of the original star's core. Neutron stars are among the most exotic objects in the universe, with masses comparable to that of the Sun packed into a radius of just a few kilometers. The explosion of Betelgeuse, the anticipated supernova, could not only mark the end of a massive star's life but also open up an entirely new chapter in the study of cosmic events and their influence on both the Earth and the universe. As we delve deeper into the potential implications and broader context of this anticipated supernova, the possibilities expand far beyond the immediate impacts previously discussed. The first aspect to explore further is the role of Betelgeuse's supernova in advancing our understanding of the fundamental forces of nature, particularly gravity. Betelgeuse is a massive star, and when it collapses, the sheer density of its core will significantly alter the fabric of spacetime. For decades, scientists have been eager to study gravitational waves, ripples in spacetime first predicted by Albert Einstein's general theory of relativity. Gravitational waves were directly observed for the first time in 2015, but most observations have involved events like the merging of black holes or neutron stars. A nearby supernova, such as that of Betelgeuse, would provide an unprecedented opportunity to study these waves originating from the core collapse of a dying star. Detecting gravitational waves from Betelgeuse's explosion could yield crucial data about the star's internal structure, particularly about how the collapse proceeds and whether the core forms a black hole or a neutron star. These observations would allow scientists to test Einstein's predictions under different conditions and refine their models of how gravity behaves in extreme environments. As advanced detectors like the Laser Interferometer Gravitational Wave Observatory, LIGO, and the Virgo detector become more sensitive, the ability to capture these subtle ripples from a supernova explosion would mark a significant milestone in the study of cosmology and astrophysics. Another aspect of Betelgeuse's explosion is the fascinating study of magnetism in the aftermath of a supernova. Massive stars like Betelgeuse have powerful magnetic fields, and when they explode, the collapse of the core and the intense forces involved can amplify these fields to extraordinary levels. If Betelgeuse forms a neutron star after its explosion, it may give birth to a particularly exotic type of neutron star known as a magnetar. Magnetars are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's, making them the most magnetic objects in the universe. Understanding the processes that generate and sustain these magnetic fields is one of the open questions in astrophysics. Magnetars are known to emit bursts of X-rays and gamma rays, and studying a magnetar formed from Betelgeuse's collapse could provide key insights into the mechanisms behind these emissions. These magnetic fields also affect how the star's remnant interacts with surrounding gas and dust, influencing the formation of new stars and planetary systems. By observing the evolution of Betelgeuse's remnant, scientists could learn more about the role of magnetism in the life cycles of stars and galaxies. One of the more intriguing implications of a Betelgeuse supernova lies in the realm of interstellar chemistry. When a massive star explodes, it enriches the surrounding space with a variety of heavy elements that were forged in its core through nuclear fusion. These elements, including iron, carbon, and silicon, are the building blocks of rocky planets, and by studying the chemical composition of the material ejected by Betelgeuse, scientists could better understand how planets like Earth form. The heavy elements produced in supernovae are essential for the formation of life, and without them the universe would be a very different place, one without rocky planets or the complex chemistry needed for life to evolve. In addition to the heavy elements, Betelgeuse's explosion could generate complex molecules like organic compounds. While the formation of life is unlikely to occur in the chaotic environment following a supernova, these molecules could provide clues about how prebiotic chemistry, the chemistry that eventually leads to the formation of life, can arise in space. Observations of the supernova's remnant could reveal how these molecules form and survive in the harsh conditions of interstellar space, offering a better understanding of the origins of life in the universe. A crucial factor that scientists would be keen to study is the supernova's influence on the interstellar medium, the vast expanse of gas and dust that exists between stars. Supernova explosions are one of the primary drivers of turbulence in the interstellar medium, creating shock waves that compress and heat nearby clouds of gas. This compression can trigger the collapse of gas clouds, leading to the formation of new stars. Betelgeuse's explosion could thus set off a wave of star formation in the surrounding regions of the Orion constellation, where it resides. The study of star formation in the wake of a supernova is an ongoing area of research, and a nearby supernova would provide a unique opportunity to study these processes in real time. Observing how Betelgeuse's shock wave interacts with nearby molecular clouds could help scientists understand the conditions needed for stars to form and how supernovae contribute to the birth of new stars and planetary systems. The Orion constellation is already known as a stellar nursery, home to several regions of active star formation. Betelgeuse's explosion could accelerate these processes, adding yet another layer of complexity to this already dynamic part of the sky. The potential formation of new stars brings with it another exciting possibility, the study of planetary system formation in the wake of a supernova. While it may take millions of years for new planets to form around these newly born stars, the ejecta material from Betelgeuse could provide the raw ingredients for these planetary systems. By studying the composition and distribution of this material, scientists could learn more about how planets form and the conditions necessary for them to develop the characteristics needed to support life. In essence, the explosion of Betelgeuse could sow the seeds for future generations of stars and planets, carrying on the cycle of cosmic birth and death that has shaped our universe for billions of years. The explosion of Betelgeuse could also have an impact on our search for extraterrestrial life. In recent years, the discovery of thousands of exoplanets, planets orbiting stars outside our solar system, has revolutionized our understanding of planetary systems and the potential for life elsewhere in the universe. A supernova like Betelgeuse could provide new clues about the conditions necessary for life to arise, particularly in terms of the availability of life-sustaining elements like carbon, oxygen, and nitrogen. By studying the materials ejected by the supernova, scientists could gain insights into how these elements are distributed throughout the galaxy and how they contribute to the formation of habitable environments on planets. Moreover, the shock wave and radiation from Betelgeuse's explosion could offer an opportunity to study the effects of cosmic events on the habitability of planets. Planets in the vicinity of a supernova are likely to experience extreme radiation, which could strip away atmospheres or alter the conditions for life. By studying how the shock wave from Betelgeuse interacts with nearby regions of space, scientists could better understand the hazards posed by supernovae to life on planets and what protections might be necessary for life to survive in such environments. This could inform our search for life on exoplanets, particularly in regions of the galaxy that are subject to higher rates of star formation and supernova activity. While the possibility of witnessing a supernova so close to Earth brings excitement and scientific opportunity, it also raises important questions about how humanity would react to such an event. Modern society is highly dependent on technology, and the explosion of a star as close as Betelgeuse could potentially disrupt satellite communications, power grids, and other vital infrastructure. Although Betelgeuse is far enough away that its explosion is unlikely to cause catastrophic damage to Earth, the potential for disruptions to our technology serves as a reminder of our vulnerability to cosmic events. The study of space weather, how solar activity and cosmic events affect Earth's technological systems, has become an increasingly important field in recent years, particularly as our reliance on satellites for communication, navigation, and weather prediction has grown. A nearby supernova could provide valuable data on how high-energy radiation from space interacts with Earth's atmosphere and magnetic field, helping scientists develop better models for predicting and mitigating the effects of such events on our technology. This knowledge could be crucial in preparing for future cosmic events such as solar flares or supernovae in other parts of the galaxy. In addition to the practical challenges, the explosion of Betelgeuse could have profound psychological and cultural impacts. For centuries, humans have looked to the stars for inspiration, navigation, and understanding of the world around them. The sudden appearance of a supernova bright enough to be seen in daylight and outshining the moon at night would be an awe-inspiring event, one that could evoke a deep sense of wonder and curiosity about the universe. Such an event could also prompt reflections on humanity's place in the cosmos, particularly as we grapple with the realization that the forces that govern the stars also affect our own existence. In many ways, the explosion of Betelgeuse could serve as a cosmic reminder of the interconnectedness of all things. The same processes that lead to the death of stars are responsible for the creation of new ones, and the elements produced in these explosions are the building blocks of life itself. As humans, we are made of the same elements forged in the hearts of dying stars, and the explosion of Betelgeuse could be a powerful reminder of our own origins and our place in the universe. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us what are your thoughts on Yaku's prediction? We want to hear from you. Thank you for watching and see you next time.